Well, hello guys, Mr. G here, and today we're going to be doing a video on rate of reaction. We're going to start answering the question paper developed by Professor Rodriguez that have a few questions on rate of reaction. So we're going to be answering these questions for a few days because it is important. It's what you are doing at school now. But before we start, please don't forget to subscribe for the channel so you can get all the notifications and videos I post on regular basis. We're going to start with question 2. I personally like to leave the multiple choice for last, so we're going to start with question 2. Question 2 says a piece of calcium carbonate of mass 0.6 gram was placed in a flask at 200 centimeter cubic of 0.25 mole per decimeter cubic of hydrochloric acid was poured into the flask. The carbon dioxide gas that was formed was collected as shown below. And then there is the setup of what happened in this experiment, in which we have hydrochloric acid and they place calcium carbonate inside. Gas was released and is collected in the gas syringe. The following balance equation shows the reaction that took place. And then you can see the chemical reaction, the equation. Why it is necessary to close the flask as soon as the acid was added to the calcium carbonate? It is a very simple question there. Well, because in the reaction a gas is released, all the idea is that the gas does not escape the container. So that is to prevent the CO2, the carbon dioxide gas, from escaping. Show by means of freehand drawing the graph for the volume of carbon dioxide gas produced against the above reaction. No values are required. Shows and call it curve A. So you have to draw a graph to show the formation of the gas. And guys, this is the graph we want. Starting from 0, because at the beginning you don't have any product. That is question 2.2. Name one change that can be made to increase the rate of reaction for the gas with the same mass of calcium carbonate above. Okay, let's go to see what factors can affect this specific reaction. Remember, there were 5 factors that affect the rate of the reaction, but not all of them can affect this reaction. Okay, so how can we increase the rate at which the gas is formed? First of all, we can change the concentration of hydrochloric acid, or let's say use hydrochloric acid with a higher concentration. That is the first option here. Let's write them on this side here. So the first one would be increasing the concentration of hydrochloric acid. Now what else can be done here? Well, increase the temperature. Remember, they're asking you for only one, but we're going to mention all of them. We can, instead of using a big piece of calcium carbonate, we can use calcium carbonate powder. So grind the calcium carbonate into powder. What else can we use? We could add a catalyst. And guys, those are all the factors that can actually affect this reaction. Note, you cannot change the pressure because they are not gases there. The gas is the product, but not the reactant. So that one is not possible here. Name one change that can be made to increase the rate of the reaction. That question is done. Question 2.4, on the same set of axes as question 2, draw the graph that would be obtained when the rate of formation of the gas has increased with the same mass of calcium carbonate. Label this curve B. So all we have to do is now, when you use one of these factors, any of those factors changes, the rate of the reaction increases. All you have to do, and we're going to answer on the same set of axes, we are going to draw a new graph. Now remember, this graph is going to be a higher rate and therefore is going to be above this one. So all the way above, it doesn't matter how above, but it's going to end in the same point, and that graph is going to be curve B, because they want to know on the same set of axes, this one is curve B, and that curve B depends on this one here. Higher rate of reaction, the higher the gradient of that graph would be. It's quite simple, guys. Okay guys, so now we are going to question 2.5. By making use of stoichiometry calculation, find in grams the amount of carbon dioxide produced in the reaction. So in this question we know that the initial mass of calcium carbonate is 0.6 grams and the volume of hydrochloric acid is 200 cubic centimeters with a concentration of 0.25. Now, to know how much carbon dioxide is released, the first thing we need to know is to identify which of these two substances is the limiting reagent. And to do that, we need to calculate the number of moles of both of them. So to calculate the number of mole of calcium carbonate, we need the formula mass divided by molar mass. And when you substitute here, guys, you get that 0.6 divided by the molar mass. You do have to calculate the molar mass because we don't have it, and this one is a 40 plus a carbon, which is 12, plus 3 times 16. When you do this calculation, you will get that the number of mole of calcium carbonate used was 0.006 mole. Now, we don't know if it's going to be the limiting reagent. So we are going to calculate, this one is for calcium carbonate. We are going to calculate the number of moles used for the hydrochloric acid. We're going to use the formula concentration is equal to number of mole divided by volume. And remember, the volume must be converted. So this one is 0.2 cubic decimeters. All right. When you substitute this here, you get that 0.25 is equal to number of mole divided by 0.2. All right. This one is number of mole, not mass, number of mole. So the number of mole is going to be equal 0.05 moles. Now, guys, you have less calcium carbonate, but it doesn't mean that it's going to be the limiting reagent. To do that, we have to go to the ratio of calcium carbonate versus hydrochloric acid. So what we are going to say? We're going to say ratio of CaCO3 to calcium to hydrochloric acid, which is HCl. And the ratios are the numbers at the front here. You have 1 and 2. So it's 1:2. So now you are going to do the following. You can use either one. You can use either one. To use up 0.006 number of mole of calcium carbonate, how much hydrochloric acid will you need? And then you do cross product there. So you will get that the number of mole of hydrochloric acid needed will be equal to 0.012 mole. And you see you have 0.05, which is more. Therefore, the limiting reagent was going to be the calcium carbonate. So now, using the number of mole of calcium carbonate, we are going to determine the mass of carbon dioxide release. Guys, same story, we're going to use the ratio. Now, for this ratio is calcium carbonate to carbon dioxide, CO2. And you can see here that the ratio is 1:1. You can see it there in the Valence chemical equation. So 1:1. Therefore, the number of mole, if you have 0.006 here, you will produce 0.006 mole of carbon dioxide. And using this one and the same formula, number of mole is equal to mass divided by molar mass, we may calculate the mass of carbon dioxide. Number of mole is 0.006 is equal to mass, we are looking for that, and the molar mass of calcium carbonate of the carbon dioxide is 12 plus 2 times 16, guys. And then the answer for the mass is going to be equal to 0.264 grams. This is the mass of carbon dioxide released during this reaction. Guys, this is very simple. It's a good question to practice because you've done it in grade 11 and 10. I hope you understand. This is the end of this video. Only question 2. Thank you for watching. Subscribe for the channel if you didn't do that yet. I'll see you next time. Mr. G here.